So here we are, Unit 1, Lesson 12, Day 1. So we have been talking about absolute value equations the last couple of days, and now we're going to start talking about absolute value inequalities. So what happens when we have that absolute value with a less than or greater than symbol as well? So it gets a little bit trickier. We have to do a few more things than just the absolute value equation that we've been doing the last couple of days, but it's kind of the same idea. We do have to make our two equations. We need to do some solving on each one, but then we also will have to be doing some shading, right? Just like we do with all of our inequalities. So when we have an absolute value inequality, we get compound inequalities as answers. So remembering those ands and ors and things like that. So let's just kind of jump right into it. Let's just do a little warm up on remembering how to solve inequalities. So go ahead and pause your video and take a shot at these two warm up problems. All right, so if I'm going to solve my inequality, remember I'm going to move the loose guys first. So I get 2x is less than 14, and then I have to divide both sides by 2, so I get x is less than 7. And if you remember how to graph something like that, I would have to have 7 on my graph and maybe a number on each side to get the idea. Since I have no underline, it's just x is less than 7, I need an open circle on the 7 because 7 is not actually a solution. Everything right up next to it is. And if I want the numbers that are less than 7, I need to shade to the left. That is where the numbers are less than. Okay, so now if I hop over here and do my second one, I'm going to have to subtract 4 from each side first. So I get 1/2 x is greater than or equal to 13, and then to clear this fraction I'm going to multiply both sides by 2. Now you could have cleared first and multiplied every single thing by 2, either way is fine. And so I get x is greater than or equal to 26. And now again, when I'm remembering how to graph these, I got to get 26 on there, maybe a number on each side. Right? And when I have an underline, an or equal to, that means that 26 is actually a solution. So I want to put a closed circle on that 26. And if I want the numbers that are greater than or equal to 26, then I need to shade to the right because that is where the numbers are greater than 26. All right, hopefully that got your brain back into inequality mode. So now let's flip over and think about absolute value inequalities. All right, so the last couple of days we've really been thinking about absolute values and remembering that absolute value means the distance from 0, right? So what this absolute value is asking is what values have a distance from 0 that is less than or equal to 3, right? So again, that's a very wordy way of thinking of what that simple inequality really represents, but that's what it means, right? What values have a distance from 0 that are less than or equal to 3? So if I look at my number line here, here's 0. I'm going to get 0 on the number line. So let's just think, okay, well, obviously I'm going to have a 3 on my number line, right? That 3 is 3 units away from 0. And if I actually have a point here that's exactly 3 units away from 0, that would work because I have my or equal to, right? So this point, 3, would be exactly 3 units away from 0. And also, I could go in the other direction, right? If I had a point over here at -3, this point is also exactly 3 units away from 0. But now I'm not just talking about equal, right? I'm talking about less than or equal to. So where are my numbers that have a distance that's less than 3 units away from 0? Well, what if I had a point here at 2? That would be 2 units away. That's less than 3 units away, right? Or -2 would have a distance less than 3 units away, or -1 or +1, right? So all of these numbers in between the +3 and the -3 have a distance from 0 that is less than or equal to 3. All right, so we can see that I have now that I have a compound inequality, and you notice that I am shading in between, right? So my x value has to be less than or equal to 3, and it also has to be greater than or equal to -3, or x's are going to be in between -3 and 3, with those two numbers being actual solutions, so I need to have the underline. All right, so a lot of times when we're doing these absolute value inequalities, the easiest way is to actually start with the graph sometimes, especially with these basic ones. Okay, so here we go. The absolute value of p has to be greater than 1. So here on this one, I need the distance from 0 has to be greater than 1 unit. So here's my point over here at 1 unit. And here's my point over here at -1, right? Because this would also be 1 unit away. But I need my distance to be greater than that 1 unit. So what if I had a point over here at 2? Well, if I had my point over here at 2, that distance would be greater than 1 unit away from 0. So that would work. But what if I had a number over here at -2? Well, that would be a distance from 0 of 2, so that would be greater than 1 unit away from 0, right? But I could have something right here or right here, all the way up until those 1s, and since I don't have an or equal to sign, just like we did on our normal inequalities in our warm-up, I have to have open circles on those 1s, right? 1 and -1. But instead of shading in between, I want distances that are greater than 1. So I need to go away from the 1, bigger numbers than 1, and I also need to have a distance greater than 1 in the other direction, right? So moving more negative in that opposite direction. So that's what our inequality would look like on this one. So notice here, when I have a greater than distance, I should be shading out. And if you remember what those inequalities look like, it would say that x has to be less than -1, or x has to be greater than 1. So there's a compound inequality as well. One is an and one is an or. And notice on the first one, I needed the distance to be less than or equal to 3, and I ended up shading towards the 0, right? And the second one, I needed a distance that was greater than 1, and I ended up shading away from 0. Greater than would be an or, and less than is a good way to think of that I would end up with an and compound inequality. It's just a little trick to use. All right, now again, those were just the basics, just a single variable, but remember that I might end up having more than just a single variable in the center. So we're going to kind of combine what we know about solving inequalities and what we know about solving absolute value equations into the same thing. So we talked about yesterday and the day before about how what this means is that this absolute value, the distance from 0, has to be less than 13, right? So that means that this stuff inside here, whatever that number ends up being, that number has to be less than 13 units away from 0. So m minus 6 has to be less than 13. But I also know that would be if I moved to the right, right? So here's 0, here's 13 units, right? So I could have a possibility where it's somewhere in between the 0 and the 13 in that direction. But I could also have the possibility where it's somewhere in between the 0 and the 13 in the other direction. So I could have that m minus 6 has to be greater than -13. Now, this is a tricky one, right? This is a place that gets students thrown off quite a bit, and it's that we forget that when we make something negative with an inequality, I have to flip my symbol. And you can kind of see it on my graph here when I show it this way, right? I want numbers that are somewhere, the distance is less than 13. So I need to somehow figure out how I'm going to include the numbers that are less than +13, but greater than negative 13. And this is a great way to show why I have to flip the symbol when I'm using my negative side. I want them to move towards 0 on the negative side, so that actually means greater than. So it's just like that when you're solving with an inequality, you divide or multiply by a negative. When I make this a negative, flip that symbol. Flip the symbol. Okay, now I do have the 13s on there so you can see how we set it up, but I actually have to solve for m. My graph is actually going to be of my solutions and not just how I set it up, but that really helped us wrap our brains around what that was going to look like. So I'm going to go ahead and add 6 on both sides on the left, so I have m is less than 19, and I am going to add 6 over here on the right, so I get m is greater than negative 7, right? So if I think about, okay, m has to be less than 19 and m has to be greater than 7, my compound inequality is going to look like this, right? Negative 7 on the left, positive 19 on the right, and I'm shading in between, as you could see with my example on how I set it up there. So my solution number line would have a negative 7 over here, and it would have a positive 19 over here. I'm going to have open circles on each of them, but I needed that distance to be less than 13, right? So that's an and, so I am going to shade in between. All right. Again, the more you practice this, the more straightforward this is going to get. Okay, so here now on my next one, the absolute value of v over 6 is greater than 1. So this distance has to be greater than 1. So if I'm thinking about how I'm setting this up here, here's 0, here's my 1, here's my negative 1, right? I need the distances to be greater than 1. Maybe I'm not going to shade just yet, but I need them to go this direction from 1, right? So I could have v over 6 is greater than 1. But I also need the distance to be greater than 1 in the other direction, right? So I'm going to have that v over 6 could be less than negative 1. And again, we're going to make sure that we flip that symbol when we make it negative. Okay, so that was just the setup, though. I want to actually solve this out and figure out what are my values of v. So to solve each side, I'm going to multiply each side here by 6. So I'm going to multiply by 6 on both sides over here. Okay, so I get, those are going to cancel out, so I will get v is greater than 6. And then on my other side, I'm going to multiply both sides by 6. Those will cancel out. I get v is less than negative 6. So I need to have v is less than negative 6 or v is greater than 6. Those are in different directions. So my compound inequality is going to look like, here, let me scooch it down, there we go. V is less than negative 6 or v is greater than 6. So there's my compound inequality answer. And then I'm going to make sure that I actually graph my solutions on this one. So here's negative 6 on the left, positive 6 on the right. Again, no underline, so I'm going to have an open circle at negative 6, shading to the left. And I'm going to have an open circle at positive 6, shading to the right. Okay, so hopefully you are starting to see some patterns here. And you'll notice that whenever our symbol happens to be less than, right, when our distance has to be less than a number, I'm going to end up with an and inequality, right? A shading in between. And whenever I have a greater than as my symbol, when I want my distance to be greater than a number, I'm always going to end up with an or inequality. So that's how you think you're less than, right? Less than, the distance has to be less than something. I'm going to be shading towards the 0. When my symbol is greater than, then I'm going to have a distance bigger. I'm going to have to be shading away from the 0. So just understanding what your absolute value is representing is the biggest key to that. All right, one more, just a little bit more complicated, just to make sure that you're really understanding the idea. So as I see this one, I'm noticing that I have the absolute value of 2n minus 2 is less than 4. So in this case, right, I want distances that are going to be moving towards 0. So this is going to be an and inequality. So one possibility is that 2n minus 2, this part inside, will be less than 4, right? That will take from 4 and move towards the 0. The other possibility is that this 2n minus 2 has to be greater than negative 4. So remember, on the one that we make negative, we want to flip that symbol. All right, and that's going to move things from the negative side towards 0, just like the other one will move it towards 0 from the positive side. All right, now I have my two equations, so I'm going to go ahead and solve each one. So I'm going to add 2 to both sides over here on the left. I get 2n, is less than 6. I'm going to divide both sides by 2, so I get n is less than 3. Okay, then I'm going to add 2 to both sides on the right. I get 2n is greater than negative 2, and I am going to divide both sides by 2 over here, and I get n is greater than negative 1. And remember that this is an and inequality, so I need to make sure that I write that compound inequality all together. So here's n in the middle. It needs to be greater than negative 1, and it needs to be less than 3. And now I'm going to actually make my graph. I didn't have to use it to set it up this time. Hopefully you're getting more comfortable without having the graph to set it up. But here's negative 1 next to the 0. Here's the positive 3. I'm going to have an open circle on the positive 3. I'm going to have an open circle on the negative 1. And I need to be shading in between because this is where that distance is going to be less than 4, right? So it's an and inequality. And there is the graph that goes along with that solution. All right, so hopefully you're getting the hang of it. This is just the intro. We'll be doing more practice with it tomorrow. But just remember to stay organized, right? Separate your absolute value and then solve each inequality. Don't forget to flip that symbol on the one that you make negative. And then make sure that you shade correctly based on your two solutions and also based on that symbol at the beginning, right? Greater is an or, shades out, away from 0. Less than is an and, shades towards the 0. And hopefully that helps you.